Cool. Okay, we're recording. We have Robert Cheong here. Thank you for coming in today, Robert, or Zooming in, Teamsing in, whatever you want to call it. Yeah. It's, what are we, episode 13, Around the Bend podcast. I've known Rob for a little while, and he has some pretty interesting actual, what do you call it, tactical, I don't know what you call it, the actual managing of certain software projects and things like that I thought people would find interesting.
Sure, yeah. Yeah, a lot of, I think it's interesting, but very background in terms of my experience. A lot in terms of kind of the data world and how to apply it and use data to make decision support tooling systems.
Mm-hmm.
So early on in my career, I started working right out of college, actually, in and around object databases. Now, object databases, not really well known or not as big a thing nowadays as it was, in the late 80s, early 2000s. But it was a thing for a while. And so I worked at a company doing really kind of big data, NoSQL, before NoSQL was really kind of a coined term. And so had a lot of interesting opportunities, building that database management system and working with various customers to see some of their really cool and insightful applications of that data. Some of my most recent experience, though, has been using some of that data to be able to do mathematical optimizations to model kind of a real world situations and examples. In the case that I used it in most recently, it was about, well, how can we use mathematical optimization to make some really smart decisions about how we allocate resources or devote resources to our various customers. And so, kind of coming into that, I had no background in optimization or mathematics. When I heard optimization coming from a computer engineering background or software background, I thought, well, optimization, how do you optimize your code? But that's totally not what I kind of got into. For me, I was fortunate enough to work with some really fantastic mathematicians who helped to kind of relate some of that stuff into real world examples. And so by virtue of kind of working with some of that stuff, it's really just kind of interesting to hear the applications in so much as the fact that there's a lot of really brilliant applications to kind of day-to-day activities that you just don't think about. And as an example of that, and I always kind of like to start with this example when I talk to people about it. Once upon a time, I worked retail. I worked at a computer store called CompUSA. I don't know if anybody remembers that, but it probably dates myself a little bit.
Someone I'm sure will.
I worked kind of the front end, so the cash registers and customer service. And me and one of my other coworkers, my other coworker in particular, did a lot of the scheduling, right? And so if you think about that, you're trying to schedule shifts for a store, and in this case, it wasn't necessarily too bad. You could open up a spreadsheet, and you could start to try to create a schedule for that, right? And so, you have various factors that you want to consider. You have a multitude of different people at different points in their life. So, as an example, we have some college people. And so, they're going to college during the day, so they can work mostly in the evening, which was kind of where I was at. And then you have people who are not going to college, so they're more available kind of during the day. And you have some people who perhaps like to have their weekends free because they like to go out and do stuff, right? So you have all of those preferences, but you also have other constraints or factors that you need to figure out, right? Like, so during the day, you probably need less cashiers because it's not quite as busy because most people are at work, versus, the evenings where more people are free, so they'll generally come in. And then, of course, the weekends are probably going to be your busiest time. And of course, you have certain laws you have to comply with, and you don't want to pay overtime and all of that stuff. And so you need to come up with a schedule. So you could do that on a spreadsheet and kind of twiddle with it, and it'll probably take you, if it's a small shift or a small crew, a couple hours, of kind of iterating back and forth and then showing it to the team and making sure that everybody's okay with it, they can work those hours and all of that stuff. But now imagine having to do that for, instead of just the front end of the store, the whole store, or a multitude of stores, right? And then of course perhaps there are even further constraints, like if there's a person of a certain age, they can only work a certain amount of hours every week, et cetera, right? And so that gets really hard. And like I said, we were doing it with a spreadsheet, kind of trial and error, but you can actually build a mathematical model for that and specify the objective. And perhaps your objective is, well, let's schedule that shift that costs the least amount of money. And all of those little rules that I talked about could be constraints into that mathematical model. And so you can build up that model, run it through a solver, and the beauty of optimization is that it will return, based off of all of that data and all of those rules, the singular best possible answer to solve that model. And so that therein lies kind of the power of some of the optimization things that we were doing. And so, that's a pretty simple example, but you can really kind of extend that further out. So, as an example, or as another example, potentially something like, project planning, right? And so, this might be a little bit more relevant to others, right? So, you have a multitude of projects, and you have a return on investment, and you have a cost, and there's certain constraints for some of those projects. As a software development manager, perhaps I need someone with Java capabilities, and who also is familiar with Linux, right? And so you can put all of that stuff together and generate a model, trying to optimize based off of the costs, the knowledge, skills, and be able to help generate what would be the best set of projects based off of the resources, the capabilities, and the return on investment that we should be working on for the next quarter or next year. So another really kind of wonderful example of potential use of optimization. And so where I was applying it to most at my last previous employment was, again, kind of how do you use these optimization capabilities to be able to save on resources? Because, well, as most companies, we want to make sure that we are keeping costs down so that we can maximize in terms of profit. Right?
Yeah.
And for various companies like the one I was working at, it's about making sure that we're not spending tons and tons on hardware and resources. And so that's what we were essentially modeling was how can we make sure that we are with the sole objective of kind of minimizing cost while making sure that we are guaranteeing certain user experience constraints, right? Because of course we still want to make sure that we're giving enough resources so that the user is having a wonderful experience and near flawless, but not so much that it's costing extra money and resources are just kind of sitting there, not being utilized efficiently. And so we did all of that by generating a nice, complex mathematical model. I had some wonderful mathematicians who were able to do that because, of course, I can't do it.
Yeah.
But then, of course, writing the software and the tooling to be able to support all of that, generate those recommendations, and then have people implement it.
So that's kind of an interesting problem because people, maybe they think computer scientists and developers are like super good at math. A lot of coding and a lot of these projects have not very little math, but it's not like to the level people are thinking about. So people are like, oh, why would you need a mathematician for this? Because there's somebody that's super specialized in mathematics. They're super intelligent in this one field and they don't understand how to code or program or, maybe they have a base understanding.
Right. So, I majored in computer engineering and that was a long time ago. And I had to take the math classes, calculus and linear algebra and other bits and pieces. They also had a computer science, track. And I know that was much more mathematics, or well, maybe not much more, but more in-depth mathematics than the computer engineering because we were kind of a nice mixture of both kind of software and hardware. But for sure, the level of mathematics that was being used, and again, like I said, all credit goes to the PhD level mathematicians I had on staff, who were really kind of doing some really complex stuff that just kind of was well above and beyond my scope and knowledge. That being said, for sure, mathematics is definitely involved in computer science and programming. Most programmers that I know have taken some pretty advanced mathematical courses. But like I said, so some of the stuff that these mathematicians were doing were just kind of well above and beyond, what I would generally expect from a programmer.
What so at Workday, what were these? So I guess in a general sense, most people know what Workday is, but if you don't, it's basically like a big ERP tool that's mainly used to track people's time and expenses and schedules in a big general sense. So just in case somebody doesn't know, I have to use it every week, so I know what it is, but some people don't. And I think they use it for posting jobs and other stuff. But what were these optimizations? Because they're not like a standard software optimization. What optimizations was Workday getting out of that?
Yeah, so primarily for the team that I was running, we were more focused kind of on some of the internal optimization capabilities. That being said, for sure, there are optimization capabilities that are end user facing capabilities, I won't go necessarily too much into those because that wasn't necessarily the area that we were focusing the most. But within Workday, again, most of it was in and around, well, how can we best assign or make recommendations on resource assignment for our customers, in terms of like the type of servers, number of servers that we're assigning, based off of things like, well, how the traffic patterns and the resource utilization and the way that the underlying systems are architected. What resources do those need based off of the type of services that they're running, so that we can really just make sure that we're assigning. I at times people would think, well, it's about saving, but I don't think it was saving. I think it was right sizing, right? Because it wasn't all about just saving. At times we were saving because we were reducing the amount of hardware we might potentially assign to a user because they didn't really need it. But at times we might make recommendations. Hey, they actually need more hardware. Because we want to make sure that based off of their predicted traffic patterns in the future, we want to make sure that they will continue to have a really good experience going into the future as their load increases over time.
Mm-hmm.
So that was a lot of it. A lot of time and energy spent because there's multiple services and each service has different profile and different behaviors and different things that you're looking for. So we would have to model various services accordingly. And then, of course, there were other like internal projects that we ran that I think were pretty interesting. As an example, we did look at working with some various teams around things like how could we optimize the recommendation of human resources, kind of going back to that. Well, if there's a job that requires certain skill sets and we have certain team members spread throughout Workday who have certain skill sets, how can we do our best to kind of match those potential employees to some of those projects?
Mm-hmm.
So there were things like that, and of course, but we had a really interesting one in particular. One of my principal engineers at the time, we were moving from one building to another, right? And so there comes the challenge of moving and how you seat people, right? And certain teams interact with other teams more than others, right? And so he was able to create a mathematical optimization model that modeled how we would place certain teams within certain buildings, taking into account, well, some people might not want to walk up and down floors, and there's time to go up and down floors and via stairs or elevators, and we know that maybe team A talks a lot to team B, but doesn't really talk a lot to team like D, right? So there's no inherent value necessarily in placing them closer together than it would be for placing team A and B. And so he did this across multiple teams to be able to figure out, well, here's a seating arrangement that optimizes across all of these teams, for time and energy needed for them to be able to communicate and all of those things, right? So again, like just simple enough things that you might be able to kind of do by hand, but really makes a lot of sense in terms of, well, if there's a way to kind of model that and come up with the best possible answer, which was essentially what he was able to do, let's use some of that technology.
Mm-hmm. Absolutely. I think it's kind of an interesting one because it's not a problem you would normally think of software engineers as taking on. And then even as a mathematician, I'm like, how would a mathematician like calculate that? Like, what's the best seating arrangement? Or like, that's one of those like problems that has a bunch of variables that's kind of hard to sort out. But
and so that, and you kind of hit a key term there, right? Is variables, right? So where does this mathematical optimization really kind of provide its value is when there are more and more variables associated to it, right? And so kind of going back to that scheduling problem, well, yeah, like simple enough with the front end of the department, but what if you do a whole store? Or what if you have to do it for a whole, a whole company, like, a whole set of retail companies, right? That's where it gets more and more complicated and much more significant, investment in time. And so being able to have these tools and be able to create this model to be able to generate that answer for you is where you get a lot more value.
absolutely. I mean, it's just, or were there, so it sounds like you guys were dealing with the internal hardware optimizations, like physically desk space. Were there any other kind of like weird use cases they got you on in that role?
Well, I mean, we had definitely some ideas of some potential use cases, right? And so really, anytime you need to come up with the best possible answer, and you have an opportunity to model the real world, and you have data to be able to do it, there's probably a good practical application for optimization. Now, I say that, throughout my work experience, my philosophy is, well, don't apply stuff you don't need because it's just kind of cool, right? So, we were
Yeah,
always kind of very careful about making sure that, the application really made sense. But, I mean, from that standpoint, one that was really kind of interesting, actually, there's probably a couple, right? And so, things like, how would you best be able to schedule like a conference, right? I think that's a pretty interesting one too. And so we actually use this internally, but I think, there were overtures about, trying to use this externally. So, we within Workday have this big conference for internally for all of the developers, and we even extended out to, I believe, just about everybody within Workday, right?
I
And so
see.
it's conferences and topics about some of the technology or some of the interesting things going on, right? And so, how do you schedule that, right? Because you want to get a sense of how many people are going to show up for which topic, and you have to schedule that based off of, well, you have maybe 2 days to do it, and you've rented out a facility, and maybe you have like 10 or 12 buildings, and each building has or room has a different capacity, right? And so that becomes an optimization problem, right? How do you assign which topic to which room, um, making sure that you satisfy the constraints of how many people actually want to come in and listen to that topic, and how much time you have, right? And so, yeah, potentially you could do that by hand, I think, but as it grows and grows more, as you have more input, more data, more rooms, more topics, more people, then it becomes significantly easier and of course, more optimal if you're running it through a mathematical model and running it through a solver. So, that's another real world example. We also floated potentially another example where, something like, you're for a college student, you're trying to graduate, and you probably want to try to graduate as quickly as possible because, well, college is expensive, right? And so, based off of that, you might be able to take in some data like, well, what are the courses required? What are the dependencies on some of those courses? Do they have to be taken in a certain order? And then you would be able to model all of that and probably be able to come up with a recommendation based off of all of that information on which classes should you take, when and where, so that you'll be able to kind of process all of that and graduate as quickly as possible, hopefully
Of
within the
course.
shortest time period, to be able to avoid some of the expenses of college.
Of course, yeah. I mean, those are just, I think you kind of hit on a key point too. Like, don't optimize unless it makes sense, because as an end user, not at Robert Half, but when I worked at Verizon, there was some things they would change like completely that we'd just kind of be like, I could kind of see how on paper this makes sense, but maybe you guys got like a 2% increase in efficiency, but all the employees are not happy. We all got kind of upset. Like, they'd restructured. I remember I used to work in a store, kind of like yourself, and they restructured the whole place to optimize it for like the clients and the customers, and they'd put these heat lamps that went, or it was like those like kind of, you know what I mean, like those diner style lamps, but they put them really low, or they got some extra efficiency bulb that was really bright compared to the old ones, but they would sit right above your head, so you'd be like cooking, like it'd be like cooking your face because you had to sit at these tables and help people. And I just remember thinking, like, somebody designed this, but they didn't really they didn't really think about all the end results of their actions.
Yeah, yeah. Well, comes from with a software development background. Of course, we want to use like the coolest, newest, latest tools, and not that I'm saying optimization is a new tool. It's been around for a long time.
Yeah.
But it's a pretty cool tool. I mean, same with like machine learning and AI and all of that stuff. And yes, there are absolutely wonderful applications of that. But sometimes you can do stuff without it, and so it's important, especially from a management, perspective, to make sure that you're weighing the cost and benefit. Can we do this? Should we use some of those technologies? And in plenty of cases, yeah, you should. But in some cases, you can do things kind of the simple way, and sometimes the simple way is good enough.
That's very true. Yeah, don't what is it? If it ain't broke, don't fix it. Sometimes is the best solution.
Right.
I mean, I've definitely seen too, just more to kind of bring it back to your specialization, like on the software development front. I've also seen, I think we've all seen where companies are like, oh, both sides where, oh, well, this is working, so let's just keep it going. Like some really old software package that should have been replaced a long time ago, or the other side where they're like, oh, we have to optimize this code and this software, and you're like, well, you actually made it worse somehow. So it's a tricky problem you get yourself into.
Yeah, I mean, sometimes it happens.
It's like you want to, I guess, like, how would they say, okay, where's our cutting off point for now? We're going to take, now let's consider optimizing it. Like, would it have to be something pretty significant, or were they willing to be like, oh, well, there's a 3% increase in efficiency possibly, so let's explore this option?
Yeah, I mean, and I think it's always going to be kind of a case by case basis, right? I mean, in some situations, for example, we were looking to do some optimization, and it was just like labor intensive processes, right? And so it was kind of one of those. Well, a 10% improvement is better than a 0% improvement, because the stuff that is being done is just kind of suboptimal, or very kind of labor intensive. So in those cases, we were just looking to make things better. But in some cases, for sure, you need to do kind of the upfront cost, and hopefully get someone like a well educated product manager who can kind of come in there and run some of those numbers and figure some of that stuff out, to help figure out, well, yeah, 3% is not going to be enough for this project to really kind of make a dent. So it probably doesn't make enough sense for us to invest, considering the cost and development and the effort, etc.
Yeah. I mean, yeah, that's a good point. I'm just always curious sometimes what causes, especially working in several big companies, like, what's that tipping point where they're like, you know what, we got to invest these millions and millions of dollars, and then at the end of it, you're kind of like, okay, why did we do that? Or, but
benefit what is going to be worth it.
Exactly. No, 100%. And it's kind of interesting. Like, are you going to be working on optimizations in the future? I know you're taking some career switches at the moment.
Well, probably not, but who knows, right? I mean, as we all kind of grow and experience new things, we all hopefully find opportunities to leverage that, right? So, it's because I'm a little bit more familiar with it than I was, multiple years ago. It's something that will always kind of resonate with me, right? So, whenever there's a possibility, I'll bring it up, right? I mean, and hopefully that's what we all kind of do is we grow and we learn some stuff and we take it and use it and apply it wherever we can.
I think I'm going to ask you the question that I'm sure you knew was coming. So, how do you think all this optimization stuff is going to change with one of these AI products, or all of them, or some open source version of them?
Yeah, I mean, it's a good question. I'm not really sure, right? I mean, I think, and all of this AI stuff is really exciting stuff, right? And I think it's going to lead to some very interesting and good things in the future. But I think that there will always have to be some human decision making on the back end, right? Someone to verify, because as things get more and more complex, we want those kind of safety checks, right? In particular, some of the stuff that my teams were doing at Workday, if we didn't get the decision correctly, we could bring down like a whole data center, right? And so, you want to make sure that there are some additional checks and balances, at least very much upfront in the early stages, right? I mean, you want to make sure that you're doing things correctly. So I think there's always going to be an element of that in the future, but it'll be an interesting future to see where all of this AI and ML take us.
Well, because if you just think from like an optimization standpoint, like labor intensive activities, there's a huge amount of arguably like labor intensive, like the lower level writing and things like that, that even though the stuff's been around like 6 months, they're like, yeah, all of these writer positions, all these editor positions pretty much are useless mostly now, like, and that's just right now. So it's like the kind of scary thing is like I have zero understanding of coding in almost any language besides doing hello Python world. But
Sure.
I can pump out a ton of code. I was doing it just like last week. Like I can pump out a ton of code on chat gpt and these on bard and these other ones, and I'm kind of curious, like, if I just learn how to read the code just a little bit, I could edit that and like be like, okay, well, this looks massively wrong, but this seems generally okay. Let's just throw it in there and get it
Well, yeah.
going.
My hope is that those tools become a tool, right? I mean, there are tools. I hope that the way they're used in the future makes it so that everybody's lives are just a little bit easier, a little bit more accelerated, and gives people the means to start and do things a little bit more rapidly. My hope is that it is not there to just kind of replace people, because I think people are creative, right? Some of the best ideas come from the least expected places, right?
True.
And so we have to be willing to listen, and we have to continue to foster that. And so hopefully those tools just make it so that those creative ideas come to light and come to fruition much more quickly. Because I don't think, at least at as far as I know right now, that it's going to be able to replace all of those things. The creativity that a human being has the capability of. I think that that's going to be around for hopefully a long time to come.
I think it will, and this is my prediction that I keep telling people is that just like calculators and Excel, let's say they increase the expected output of like an accountant or a mathematician, I feel
Right.
like for a lot of engineers, all these AI tools will just bump up. It's like, okay, so you can be 70% more productive
Sure.
because you're really not doing that chunk of work. So your overall output expectation will be over here. But in 5 years, once people learn how to use these things more efficiently, they'll just be like, okay, it'll kind of be like just like, I don't know, people understand how to use like the, what is it, before all the AI, there was like those tools that could pump out a lot of code, or people were like copying pasting code sections
Sure.
off Google and things like that, or generative code algorithms. It's like people have already been doing that, so the expectations of a software engineer now are higher than they were 5 years ago. But there's a lot more tools that, if you had like the same output level of a software engineer in 2012 compared to now, you probably wouldn't really have a role. You know what I mean?
Right.
But everyone learned, oh, I can just use this tool, do this thing, that, the other, and you're still working 40 hours a week. So I don't know.
Right. Yeah, yeah, right. So hopefully it's going to just continue to improve everybody's overall efficiency.
Yeah, I kind of feel like there's not a lot of people that are in the, it'll give us a 30-40% bump in productivity overall. It's, people are either like ultra positive or ultra negative. Like we're either gonna have like Utopia or Terminator. Like,
Yeah, well, I mean, there are some of those concerns, and probably some of them are a little bit valid. But like I said, it'll be very interesting to see how all of it evolves and how all of it plays out.
no, exactly. Do you think there's any what is it? Any other kind of cool topics you wanted to delve into, or kind of jump over while we're here?
um, I mean, there's always lots of cool topics, but we could probably be rambling on for forever. So,
Yeah.
I think we're all right.
Okay, cool. Yeah, and I mean, Rob, you could always be one of the. I have some repeat guests that I have slated up, so there's always time in the future to jump on another one of these, and maybe in 6 months we'll have, I don't know, Chat GPT will have done my job and your job. Who knows?
Maybe, who knows?
It'll just be making my podcast too. We'll find out.
Yeah, right.
Cool. Hey, well, thank you for taking out the time. It was fun. And definitely, I think that optimization, it's not the kind of optimization people are thinking about. So I think they'll have fun with this one.
Absolutely. And thanks for taking the time and having me on the show.
Yeah. You have a good day.
All right, you too.
Peace.